So in the past couple of videos, we've been talking about green roofs and the kind of benefits and challenges that we are facing with implementing these regenerative design features. Similarly, I want to talk about green walls as well. Again, sometimes they are called or referred to as living walls as well, so there might be different terms available. But in essence, what they do refer to are these kind of buildings that feature a facade or other types of elements that contain plants again within that building envelope. This specific example here, that one's from Paris. It's l'Oasis d'Aboukir. It's a road in Paris in France, and it was built in 2013 and designed by Patrick Blanc. He is a French botanist and landscape architect who's kind of devoted his life to studying plants and many benefits to human beings and the ecosystem, of course. And he's sort of the inventor of these living walls that we can see here. Rue Aboukir features 7,600 different plants on that facade. And they come from 237 species. So as we can see, of course, there we go. That's the building beforehand, just going back quickly, and that's what it is looking now. So obviously he's taking the opportunity to implement a feature on that, leftover kind of facade that is really unproductive in its original state. And by adding all these plants on the one hand, of course, he's providing a habitat and an ecosystem for different species that share these urban spaces with us, like all the pollinators, the bees, the insects, but also, of course, enhancing the quality of that public space for us living there as well, not just from a physical perspective, like this wall, of course, is improving the temperature around its environment, it's improving the air quality by filtering some of the pollutants, but also sort of providing a mental and psychological benefit for us. It's proven that it is more beneficial to look at greenery, any type of plants, as opposed to just looking at that really dull facade. Patrick Blanc, he plans these features very meticulously. So he sketches out how all these plants are supposed to be interacting with each other. He plans them very precisely, also in how which plants go well in that kind of environment, given the orientation of the building and everything. And he sort of designed this wave-like pattern that we can see on the right-hand side with all these different plants. So it's a very beautiful, very meticulously designed feature. On the bottom here as well, and I will link them in the description as well, you'll find all the links where I got all that information. Of course, there's heaps of other research available. This is just a brief overview of what's possible and what kind of systems they are. A very similar kind of approach in London. Again, we have that kind of empty facade on the side of a hotel, of an existing hotel. This specific green wall has been designed by Gary Grant of Green Roof Consultancy. I assume it's a UK firm that has done that. It is considered to be London's largest living wall. And it specifically was implemented to combat that kind of surface flooding that we have very often in these urban environments, and also, again, to mitigate some of the air pollution that there is. It is also attracting pollinators around the area. So again, the plants was very specifically chosen to be on this kind of feature. The wall, or this facade, is 21 meter high. It features 10,000 plants, and it has a total of 16 tons of soil. So again, if you think about the green roofs, all that soil and all these plants, they have a massive capacity to store rainwater, and of course not only releasing it at a slower pace if there is any excess water that the plants do not need, but then also through evaporation, kind of giving it back to the environment, therefore mimicking or reintroducing that natural cycle of water cycle that we find in nature. These plants, they are also fed from a water tank that is positioned on the top of the roof. So it will collect rainwater, it will store it as much as it can, and then gradually give off that rainwater to feed these plants. Because again, with any kind of living organism, they don't just, in this specific case, they don't just need the construction that is holding them onto that building envelope, but they also need a medium that is nurturing them. So on the one hand, they need some kind of soil or substrate, and they need water that provide the ideal growing environment for them as well. There's a little close-up of this facade as well. Might not be as poetic as Patrick Blanc's facades, but nonetheless looking much nicer than just an empty concrete wall as well. London, as many other cities as well, is sort of promoting the idea of SUDS, which refers to sustainable drainage systems. So again, because we want to mitigate that kind of that problem that we get of excess water that is coming through these really extreme rain events that we are seeing more and more often these days. So having or reimagining what a drainage system within an urban context looks like, these features are incredibly valuable on top of all the other benefits that they are providing as well. I also think that these systems are really valuable to be implemented on infrastructures like this example here. It's the Millbrook roundabout. I think it's also in the UK. So if you think about your daily walks, your daily commutes, and you think about these kind of empty spaces, or I'm sure there's a heaps of an opportunity and potential to implement these features in a quite easy way, and again benefiting us in so many ways. Here's a detail of one of those systems. It's a patented system by Biotecture, a firm from the UK as well. It's their hydroponic system that they developed, and you can kind of you can have a look at their website as well. It's listed below. They have quite a few resources as well. The way that it is built up, and let me quickly grab a pen here as well. So on the back here, oops, that's not the pen, let me see. There we go. On the back side here, you have your structure. So that can be any type of construction that your building features. So whether that's a timber construction or concrete or anything, as long as it has the dimensions to also hold that additional weight of the facade, of that living green wall. And having said so, of course, any type of facade will need a construction, and it will contribute extra weight. So your building will be capable to hold that anyways, yeah. Then of course, on the outside, on the exterior side of your envelope, you will have a waterproofing system that will make sure that your construction system, including the insulation, which is not really highlighted that well on here, but including the insulation, all of that is protected from any rainwater from coming in. Again, that's a normal element that you would find in any envelope design, but of course it becomes even more important with a green roof that has an active kind of watering system very close to that layer as well. Then on top of that, we have some kind of mounting system that holds the railing where the green roof is attached to, and it also holds the watering system here as well. So there's a piping system in the background that is running through the entire, you can see it here on the left side as well, that is running through the entire green wall and therefore feeding the plants as well. What is really important here is that when you attach these systems onto the structure on the back of your wall, you have to make sure that when you penetrate that waterproofing system, that it then is sealed off again, so none of that water can then leak through these little joints and assemblies onto your structure and eventually damaging either your insulation or your construction with the water that might seep in. So on top of that, these ones here are made out of aluminum. So on top of that construction is a kind of grid, which is shown here, that is attached to that subconstruction, and in between sits this kind of substrate element that provides or holds on to the plants, and the plants are then inserted into this. So all of these come together and they form that system that we can see in the section on the left here as well. The plants again have to be chosen very specifically depending on the location on your site, on the orientation, the kind of environment that's already there on your site as well. There's many different systems that work similarly as this one. That's just one example. Sometimes you see these kind of systems where they use more like planter boxes types of attachments, or you might see these like fabric sort of bags that they attach to a subconstruction, but the overall principle is quite similar as well. I think there is a bit of an innovative thing to happen as well, so you might come up with an idea of your own as well in your research. Another type of green walls that we see quite often are using or utilizing something more like planter boxes, like in a very well published and quite famous building in Milan in Italy, Bosco Verticale by Stefano Böri. It was completed roughly in 2014. So these two towers in the city center of Milan, they feature, I don't quite know how many apartments, but each of them have a balcony with a very intensive vegetation around them. So it's a very dense, it's a bit of a pixelated image, apologies, but a very dense vegetation. What is really important here as well, that and I'll quickly go back, especially given the height of the buildings, you would assume that on the top of the building you will have higher wind speeds. So Arup, the global engineering firm, they have made simulations and assessed each of these facades in terms of their ability for planting specific trees and everything, depending not just on the solar, how the sun is reaching all of these facades, but also thinking about the wind. So one of the things that they then had to implement were a couple of safety features as well. So it's not just that romantic idea of having a little garden on your balcony, but you have to make sure that these are stable as well. So what we don't see in that first image is that some of the trees that are higher up on the building, their kind of root package has been secured with this metal cage onto the planter boxes. So in case the trees are falling, for whatever reason they are not falling over the building and potentially hurting someone or damaging something else. Most of the trees, you can see it here. I'm gonna grab that pen again. It's very light. There's a cable as well that is holding them. And again, the trees further up have that additional metal cage as well. You can see a little detail of them planting the trees there as well. On top of, in addition to the actual planting of the trees, you can see an image here of one of the balconies, that kind of atmosphere that they do provide. They also released 1,200 ladybugs once they completed the project, so that kind of promotes that initial stage of that ecosystem. Of course, I just want to reiterate again, you want to be very precise with what kind of plants that you're introducing in that site. On the one hand, you want to make sure that these plants thrive in that ecosystem, in that environment, but you also want to make sure that they are not harmful to the wider ecosystem, because of course you are you're not in a contained kind of environment, they will spread eventually as well. A similar kind of strategy is here seen in a factory in Ho Chi Minh City in Vietnam. It's a slightly different application. There's a close-up here. It's a ground floor. The plants kind of sit in these planter boxes that are held up by the structure. Of course, here one of the very important factors is kind of promoting that ventilation across the building, thinking about Ho Chi Minh City, a very humid, a very warm climate that we do have there. So on the one hand, they form a solar, like they provide shading, so the solar gains inside the building are minimized, and they also cool down the air that is coming through. So very simple, a very, very simple approach, but it looks really beautiful as well. And of course, again, that idea of giving back the land that we take away by constructing our building on that site. So we're kind of giving back some of that ecosystem again. And especially in some of these countries, we tend to seal off all the surfaces, and therefore interrupting these natural processes that are happening. Another example here, that's from Switzerland, Buchnerbründler in close to Bern. Again, we have these type of planter boxes on the facade, and on top of that, you can see it's not an amazingly good image as well. I'm a bit strange. There's a close up here, maybe. Yes, yeah. You can see this kind of metal wire as well. That on the one hand, it is performing as a protection for people to not fall off the towers, but at the same time, the plants can actually grow up or downwards again as well. So you don't just have trees or bushes that are growing in one direction, growing upwards, but you can have different kinds of plants that can utilize the entire facade. There's a little detail on the right hand side. Again, we have these planter boxes features, and the plants or the vines can use that metal net that is around the building. These specific planter boxes in this project, they have a sensor within them, and there's an irrigation system that will automatically water these plants throughout the building, so it's not left to the occupants themselves to tend to these plants, but it is done for them automatically. And I would assume that Bosco Verticale, the Italian example, probably has something similar, because these buildings kind of like they literally live off that green image that they provide. So obviously you want to make sure that they always retain that kind of greenness. And if you have one of the inhabitants or occupants that is not looking after these plants too well, is not maintaining them, it might actually cause not just an ecological, but it's also causing an aesthetical problem that you want to make sure that is taken care of. Of course, with this specific building here, it's not the most, as you can see, it's not the most sustainable building in terms of its material choices. There's a lot of concrete that is being used, but we are focusing on the green wall feature here. And then last but not least, who knows what the future will bring. This is an example of some of the research that is happening at University of Virginia at the moment. I would assume many universities are looking into similar kind of technologies, and they are looking at printing, 3D printing, what they call living soil. So here's an evolution of 48 hours, 96 hours, and 144 hours. So what they are doing, they are printing this kind of, I would assume it's a more sustainable kind of concrete-like material, almost like rammed earth, that they are printing on a path through a nozzle, and that has some kind of greenery that's then growing within that medium. So who knows, maybe we will, in the future, we will kind of, that distinction between structure, material, and plant, it's not happening in individual layers, but it becomes a new material and a new technology. Might be quite interesting to see what is going to happen with these ideas as well. Perfect. So that's a little overview on green walls, the kind of applications that we have, and a little glimpse of some of the details and resources that are around. So I do hope this is helping you for your developing your own projects as well. I'm very interested to see what kind of ideas that you guys are coming up with.